Let's dive into the world of progressive web apps. This presentation will cover the architecture and offline capabilities of PWAs, offering insights into how they function and why they are increasingly popular in modern web development. So, what exactly is a progressive web app? Progressive web apps are web applications that use modern web capabilities to deliver an app-like experience to users. This means they combine the best of both web and native applications. They're essentially websites that can be installed on a user's device, offering features like offline access and push notifications, similar to native apps. They are discoverable through search engines like regular websites, but provide a more engaging user experience. To understand how PWAs work, let's explore the core technologies behind them. First, we have the Web App Manifest. This is a JSON file that provides metadata about the app, such as its name, icons, and display properties, which is essential for installation. Next are service workers. These are JavaScript files that act as a proxy between the web app and the network, enabling background processing and caching. And finally, HTTPS. A secure connection is required to ensure the integrity and security of the app's data and functionality. The architecture of a PWA can be broken down into distinct layers. At the top, we have the user interface layer, which is typically built using modern JavaScript frameworks like React, Vue, or Angular. Below that, there is the service worker layer, which manages background tasks and caching. Next, we have the cache and storage layer, which utilizes browser storage mechanisms to store assets and data for offline use. Finally, there's the network layer, which handles communication with the server to retrieve data and resources when available. Now let's focus on service workers. Here is the code snippet that shows a very basic service worker registration. You first check if the service worker is supported by the user's browser by checking if service worker exists in Navigator object. Then you register a JavaScript file called sw.js, which contains all the service worker functionality. After the registration is successful, a success message is displayed, or the error message in case of failure. After a service worker is registered, it goes through several stages, including installation, activation, and fetching. It can also handle background tasks, manage caching, and provide offline access to the app's resources. One of the key benefits of PWAs is their ability to cache resources for offline use. There are several caching strategies that can be employed. Cache first. This strategy checks the cache first and falls back to the network if the resource is not found. Network first. This strategy tries the network first and falls back to the cache if the network is unavailable. Stale while revalidate. This strategy serves content from the cache while updating it in the background. And cache only. This strategy always serves content from the cache. Let's take a look at how caching is implemented in a service worker. The code snippet shows a sample install event listener. Inside the install event, we use caches to open method to open a cache storage named v1. Then cache.addAll method adds the given array of resources like root, style sheets, and JavaScript files to the opened cache storage. So when the service worker is installed, it opens a cache storage and caches the required resources. This way, the resources are readily available when the app is offline. Thanks to service workers and caching, PWAs can provide robust offline capabilities. This includes app shell architecture, where the basic user interface is cached for immediate display, data synchronization, which allows data to be synchronized between the app and the server when the network is available, and background sync, which enables tasks to be performed in the background even when the app is closed. Background sync allows PWAs to synchronize data with the server even when the user is offline. The code snippet shows service worker code. First, an event listener is attached to sync event. If the event tag is background-sync, then a function called doBackgroundSync is executed. Also, a sync is registered with the tag bg-sync. So after the user performs an action, the data is queued, and the sink is registered to wait for network. Once the network is available, the data is synchronized with the server, and the sink is completed. Finally, let's summarize the key benefits of PWAs. They offer fast performance, with instant loading and a smooth user experience. They provide an app-like feel with a native-like user interface. They enable offline access, allowing the app to work without an internet connection. They have low storage requirements, being smaller than native apps. They offer auto updates, ensuring the content is always up to date. And they are cross-platform, working on all devices and browsers. PWAs are truly building the future of web applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.